Hello everyone. In this lesson I want to share with you how to connect Google Firebase to your project, and you can share any data from physical devices and sensors between your remote subscribers, and you can manage this data. So first of all, we have to register in Google Firebase and go to console. So when you register, it's very easy, and attach your Google account, then press the Google console. I already have a project. Here is it, but let's go from the first step. Let's create a new project. First of all, robotics test. Okay, then press continue. We can enable Google Gemini, enable all these functions, then select an account and create a project. We will wait till the project will be built and all the data. Push it to your Firebase console. Then our next steps. Okay, this is our project. First of all, we should to set up a Google authentication. Then press this gear and project settings. Oh, sorry, not build. First of all, press here and authentication. We should to enable an authentication. Press here, then enable an anonymous authentication, because if you want to set up how to sign in with credentials, it's another topic. We will left it for another lessons for the future. So then we should to press this gear and project settings, service accounts. We will paste this code. We need a Java code. They don't have a Kotlin, but we convert it to Java. Then generate a new private key. Yes, will be a new JSON file. We have to copy it, for example, to our resource, but I already generated this Firebase service account. Let me paste it. Yes, so I will not show you this account, but you can generate your own. Then let's rename our rename lesson 12. It means Firebase DB. Okay, perfect. And the same as here, lesson 12, because we will use this parameter in the future in this lesson. actually. So yeah, Firebase DB. Okay, what do we need? First of all, we need to add the dependency. Let's go to our POM file, then scroll to down to the end. Okay, you have to pass this dependency and synchronize POM project. Okay, it's easy. Then we have to create a database. Okay. First of all, we have two databases in Google Firebase. I'll explain the main difference. We have a real-time database, and we have Firestore database. What's the main difference between these databases? If you're familiar with SQL databases or relation databases or not relation databases, so real-time database, if we will take a simple explanation, it's a huge JSON file. So this is a non-SQL database, but classic database with tables, with rows and IDs, keys. This is a Firestore database. So let's create a database for it. Database ID. Okay, database ID default. You can choose the location server and start in production mode. We can set it later, but I suggest to set the parameter start in production mode. It's allowing to read and write from database. Okay, it's preparing a little bit. Yes. So start the collection. What means a collection? Collection, it's a table. Let me start the collection. 1 second. I will find the names of our connection and okay, so this is the name of our database. For example, we want to store a distance sensor values from our distance sensor. Okay, collection ID. This is the name of database. And we have to set SQL fields for our table. First field always should be a key, an ID of our record inside the table. You can generate these IDs 0-1, but the easiest way it's set as after ID. It always will generate okay. What fields we want to set up for our database? We have to know from what device we're getting a parameter, because we can store in one table data from multiple devices. So I believe it's connected with config name, because we use different configs, like here. And here we have a config name parameter. We can copy it. Okay. And field name config ID. Parameter string. Then sensor ID, because we can have multiple distance sensor in front of your device, from the bottom, etc., etc. For example, it's a first sensor in our hardware configuration. Then we should to set a time of our record to build charts, for example. Okay, time. It's a number. No, time is actually a timestamp. And set something necessary. It's just an example. Okay, then we have to set units, because in our we converting distance data, we can convert it to centimeters or to inches. So of course, fields unit. Okay, and last field value. Value, it's a number. It allows to like write a float values. Okay, and save. So when we add data from our application, we will see multiple records of it. So this is a name of our records. This is an ID, and we have config ID, sensor ID, time. It's a Unix time, unit, and value. Okay. That's all. Let's go to our project and start creating. Okay, we have a brain package. Let's look to our let's look to our main thread code. What do we have? We have an avatar, this instance of class, including everything about our hardware device. So we controlling our hardware devices, like print to display, track distance sensors. We have a configuration as well. And what about the instance, the entity, what will control everything between our logic and our hardware layer? That's why I created a brain package. So let's create brain package. Let's create a brain class. Brain. Brain class. Okay. Perfect. What we should include in our brain? Of course, we need, so let's imagine this is not a physical device, this is an alive creature. Brain controls everything. Brain controls our body. So we need references to our body parts. All the references, including in avatar. Yes. We have a package network. Perfect. Let's create in network package. Let's create another package like databases. I'll show you. We can have multiple databases, like a remote database in Google Firebase. We can have a local database. We can have another databases. So let's make our architecture flexible and extendable. Okay, here we will create a package for Firebase. Yes. And let's create an interface what extended all type of databases and a constructor for it. Okay. Not here. Not here. Well, I'll create it here and move it because it's difficult to hit in right package sometimes in IntelliJ IDEA. Okay, data base initializer. Yes, an interface. Not in Firebase. Firebase, it's implementation of our interface. Okay. Perfect. What we have to implement here? First of all, fun init alias database. So literally connect to Google Firebase database from here. Okay, then let's make some function like read and fun write. Okay, but what we can read or write, we need to know a name of our table or its naming collection in Firebase, but it's a average table from SQL. Okay, what is it? So we need a table name as string, and we need data for writing, and it could be any data. You never know what you want to write. So for example, for this table we should to generate data class with these fields, but in other tables it could be a different data, even like a one number or boolean value, anything what's possible. So data, we have a magic class in Kotlin calling any, and it could be anything. The same with write, but for write data always should be not null. Okay, and let's create a companion object for here for this parameter. So we should to know this name. Yeah, I already typed it. So this is and let's implement the instance of this interface. So we creating an instance of Firebase. Firebase Firestore database. Why Firestore? Because we have different type of database, so we creating a logic especially for it. Okay, perfect. What we need to extend our database initializer and override all of it. First of all, we need an instance of our database db Firestore. Now let's set it to null for now. Then we init our class and create and call this function. Yeah, makes sense. I'm sorry, what I'm doing, I don't know. Yeah. Everything about network connection, I strongly recommending to wrap into try catch. Logic, yeah, exception, and here we can know what something grammar, because you never know, do you have a connection, wallet connection or not, or maybe your secret Firebase servers account file is invalid. Okay, so we do have, when we generate a server's accounts, we have these parameters, we can copy it, and when we pasting it, you can convert it to to the Kotlin. Okay, but first of all, we have to generate the path to read this file. So while res equals Java class loader get resource and a resource name, rename, copy this name, boom, it's okay. Then service account, we destroy this, no, so yeah, file input stream, but we have res and pass to this res. Okay, then everything options, and we have to set database URL. So set database URL, you can find it actually, I don't know, project name. Where is it? Okay, so I'll copy this parameter. I forgot where I found it. So this is like your maybe this is robotics test. Yeah, this is, I don't know. Robotics public default RDB. So let's see all project, robotics task, robotics public. Where is project ID, I believe. Okay. Project ID. Robotics public default RDB. Somewhere here. Let's Google it. Firebase address. Okay, where is it? Oh yeah, so it's here. See all projects, robotics test, remote. Here is it, default. So let's copy this database URL, then we make a connection and db get a reference Firestore store client from first package and get Firestore. Okay, perfect. Read. We will implement. It's not the topic of this lesson. We will implement it in the future if we need. But for write, we can set it. So for write, of course, we need a try catch block. Catch exception, yes. And for write, if db not equals to null, it means we have a valid reference to our database with remote connection, with open remote connection. We can push any data. We need to get the table when we can write it. So we need a reference to this table. well, collection. They calling all tables in your database as collections. So db, as it's nullable, but we already made it verification, so it's not null, we can call it. And collection, which collection? We pass this parameter and documents, and collection set data. Very, very easy. Perfect. Let's make a specific class to logic to get an instance of our Firebase database. For example, we can have here another packages with another database, like local database or your own server database. So we need like a manager to manage all these cases. So we will create here in databases class database connector. We need to call a type, which database, what type of database we want to. So let's create an inner enum class like database types. Okay, Firebase Firestore DB, and for example local DB, but we will not implement it. Anyway, we need to have it. And then type as incoming parameter and database types. Perfect. We need an interface, so we need an instance of this class, but it's extending our interface, share interface for all databases, and we can set it here. Private latent var database connector database initializer. Yes. Okay, and init this database connector manager when type database types is as here, we creating an instance. Our database connector equals to Firebase database. Yes. No. Here is it. Yes. Okay. What else? Copy here to do, and we always can set else a parameter as markup and do the same, and it will be a manager for reader and write, and we need two public functions like read from db parameter name as string and data as any data. Okay. Database connector, read, and pass these parameters, boom, and data. Because here we can have keys if we want to read from database, from remote database. We can have like this is a table name, and this is a key of our, if we storing some persons, or we need to get, for example, distance measure value for a specific time, or get everything. So we should to pass a filter parameter. And another function, write from DB. The same, but write. Very easy. Okay, let's return to our brain. Private late init var the data base fire store database, but not this one. Database Firebase Firestore, yes. Database connector, database connector type, and I'll explain it a little bit later. For what we need two threads. If we're listening and writing different sensors, we need an array with different threads. Until this thread is alive, we writing something to data and listening some devices, listening some parts of our body, signals from it. So we need like threads. When we want to stop to listen, we just killing this job. So we private var devices red scope array, and this is a mutable map string and job, and it equals to mutable map. Yeah, import a job like that. Private fun init. This function we will call from the builder. We will create a shadow of brain class. It will be the builder, and it will return the compiled brain object instance of this class. For init, we need init databases. We can add something else, like make a self-testing to our device, to our robot, like some movements. So yes, we can actually, in the future, we can move this logic from main thread, like we print something, we call some network requests, we will move to brain. When we need, we like launch everything. Then fun build we need avatar, references to our body parts, and it will return the brain. This avatar equals to avatar, then init. We call init function because before init we need to initialize avatar to references. Okay, init, and then return this. It means this instance of this class. Okay, and let's create private fun init databases. Okay, and we can call it from interface what we made. So database firestore equals database connector type. Which type? Database connector Firebase firestore. Yes, perfect. Then a public function what will be available from main thread. So we will have an instance of our brain, and from here we can read something to memory. From main thread we don't know which database we use right now, like local database, logging, remote database, Firebase, something else. We just say to our brain, please, like fun read from memory, and our brain managing where the brain can get this information. So for now we can have only one database. So parameter name, this is a name of our table, and key any. If key equals to null, we parsing all data from this table, all records. Okay, I guess we already have database Firebase firestore, read from DB, and pass these parameters. Perfect. Okay. Okay, yeah, maybe we can set like that. Yeah, read from DB, read from memory. Fun. Write to, or no, remember to memory. Let's make our brain more humankind. So I want not to use standard convention of function name like read to DB, write to DB. Let's read from memory or remember. It sounds great. Okay. Add these parameters, but it's not a key, it's a data, and it always shouldn't be nullable, because it's not make sense if you try to remember nothing. Yeah, it sounds hilarious. Write to DB, parameter name and data. Yes. Okay. What else? We want to say to our brain from main thread when we want to start listen one of our body part, like one of our sensors. So let's create a function for that. Start track device. Okay, parameter name the same. It will be the name of our sensor. Device position. Device position. Int. By default, if it's null, we listen all our sensors. If we have a pack of same type of sensors. And look, what else do we need? From here, we calling from our avatar start distance measuring. By the way, we can move this logic into the brain package, into the brain class in the future, but now it looks okay. So we have a periodic time. Each new second we getting a parameter of our distance, but we don't want to write every seconds to remote database. It will be too heavy and too much load. So we can like listen every seconds, but push data to the remote every 5 seconds. Okay, so let's logging period in millis. It's a long, and by default, for example, it's 1000 milliseconds. Okay, when parameter name, we have a main parameter name. Okay, I prepared a companion object for we should never use hard-coded names. So because if you change something in one place, it will be an exception in another place. So we have a parameter name for distance sensor. Sensor distance. Okay. When parameter name is distance sensor, we create a function subscribe to distance emitters. Okay, and we should to receive device position and logging in mills. Perfect. Let's create this function. We already created. Let's look on main thread where we getting our distance. We have a network emitters and we have a distance emitters in the same package. In the brain, we have two companion objects with Kotlin flows. Okay. So here we private fun. Let's copy here, but we should do add int. By default it's null. If we want to listen all the sensors and long equals like here, Okay, looks great. And let's create some logic. This will be the most difficult part, but not too long. So we need, if we want to change a periodic time, we need to know when we launch it to listening our sensor launch time system current time in millis. Perfect. Then we have to create a thread scope, like a coroutine to subscribe and do all the needed job, and then store it in our array for all, because you can listen one sensor, then another sensor, then third sensor, and all these threads should be independent from each other. So let's create like a red scope. It's a coroutine scope, but job, then plus dispatchers IO and launch. Oh, my bad, mistake. Yes. Subscribe to our, because from main thread we, where is it? We calling a function like start measuring. Distance emitter emit flows to all our project, and we can subscribe it from multiple places, and from each package, from each class, we will getting data at the same time. So we get data from main thread, and we will get the same data at the same time in our brain logic. Okay, distance, no, not this one. Distance emitters, distance sensor, collect data distance. Okay, if we should to push data to the remote database only if the time is already like the period already was passed, because we can get the data like every 10 milliseconds, boom, 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 new data, but we don't want to push it. We want to push it only if periodic time in millis was passed, and it's time for next push to the remote. Next package. If system current time in millis more or equals to launch time plus logging period in millis. Yes, perfect. Okay, in this time we calling this function remember to memory, because we can set directly from main thread, or it will call this function every time when we get emitted data. Remember to the memory. Parameter name, database initialization, the name of our table, then data data read No, remember, yes, data. And here we should to set a data class for these fields, specifically for this table. So I suggest we where our all data classes. So let's create some package. Yes, so from here we can set here refactor, rename the package will be data but local. This data classes for local configuration, for local logic. So a little bit, we don't need this one. Delete, yes, perfect. So we have data local and create another package, data remote. Okay, so in data now we have two sub packages for local data classes and for remote. For remote we create a data class distance. So as you can see, we have a distance, but this is for local logic, and we have a set distance to this table, totally different fields. Okay, no problem. Let's create, well, let me copy everything. So this is the same fields and type of fields from time unit. In local logic it will be long unit string and value it's float. Okay, then data, it's a distance from remote. Okay, from remote okay, config ID avatar. Okay, we need a configuration from our avatar. If we make like that, private set, we can read the configuration, but we can't override it. Avatar, okay, configuration, config name to string, then sensor ID, distance, sensor ID, we what is it? Here is it, from sensor position. When we emit data, we write a sensor position. So distance, sensor position to string, time, we add time low. We need a low time. This is a time when the data was emitted. Unit CM. You can write your own logic, like when you want to write inches, and distance 2 centimeters. Perfect. Then we need to reset launch time, system current time. Perfect. Okay, so 1, 2, 3. And after all, when we created our coroutine scope, we have to add it to device array. Let's add it as parameter sensor distance plus sensor position device position. Device position to string and our thread scope. So what it means, we adding to map this coroutine and attach it to this key. This key, it means device sensor name and sensor position, and we all the time we can find it, use this key. Okay, what else? We forgot to create start track device, but we forgot to create a function to stop track device. Okay, this what's we don't need a periodic time, but we need these two parameters. And how to stop this logic? I guess you already know. We should to find this and cancel this coroutine. Then I suggest to set it to null. It's like a double protection or triple protection. And remove this key and remove it from main thread. Okay, what else we need? We need to create an instance of brain and look on our avatar. We have an avatar builder. We can make the same builder for our brain. Okay, it's like from here in core package. Let's create brain builder. Let's imagine if we can rebuild our brain builder in real life. It would be funny, like update our brain. Everything what we need. Avatar, yes. So let's set it private val avatar and fun build. equals brain build avatar, and it will return, let's look to this function, it will return the instance of this class. So it will build itself and then return the object of this class. This is object-oriented languages architecture. I love it. It's much more powerful as functional languages like JavaScript and Python and etc. etc. And Kotlin language has all the advantages of Java, like performance, multi-threading, object-oriented, plus some fancy features of Kotlin. A lot of fancy features. Okay, let's create the references of our brain. Late init var brain, where we have an init function, and brain equals brain builder, avatar equals avatar build. Yes, call this function to build. Okay, everything should works as expected, I hope. I don't know, I tested this code, but I'm writing in from the beginning right now. Okay, so let's add, when we start to measuring, we immediately start to write distance sensor data to Google Firebase. Brain start track device, parameter name, it's a brain, parameter sensor distance we want to track, device position null, it means for all the devices, and logging start win, what the fuck, logging period, for example, each 5 seconds. We will see the difference. Distance sensors will emit the data each second to local console, but the data in Google Firebase will appears only each 5 seconds. That's what I want to teach you. Okay, what else? Brain stop track device, brain, and just set the name of the sensor or device or part of our body here. Okay, here actually we should to set this name. Yes. Here we set it. So, and you can, for example, if you set like here, position, device position is 3, but here you set it to null, or for like a first device, it will not stop the listening the sensors, because we want to manage each sensor separated. So you can stop to track only second sensor or third second sensor or all the sensors? Okay. I hope it will work. If I didn't forget anything, I hope no. I'm going to press the button. It's still launching, yes. So I'm going to press the button and we will see emits of our data. Okay. So it's starting to measuring. As you can see, it's each second, very fast. But not robotics test. Let's jump to our public. Okay, we have a new data, and oh yeah, it's emitting in real time. As you can see, it's emitting only each 5 seconds. So here in console, it's emitting much more often, as you can see, each second. But in Google Firebase, it's emitting only each 5 seconds. If you set it to like each second or each half of second, it will emit much more often. I believe that's all. I congratulate you, all you guys. It's really like a advanced level of coding because we combined all the layers from very low physical electricity layer, like works with displays, generate PVR signals, PVR modulations, work with engines, with servo motors, and we push the data from physical sensors to our Google repository. By the way, if I press the button again, it will stop to emit the data. Yes. So I pressed the button and it stopped to emit any new data. It's not refreshing. Okay. So yeah, everything works as expected. It's very cool because, for example, this is a physical device, smart robot. In the future, we will connect an artificial intelligence. By the way, I watched an NVIDIA GTC event this year. It was like 3 hours ago, and they share it as open source code for new robots libraries. I want to touch it, to try it, and share this knowledge with you. It calls Grok, something like that. No one saw this code so far. I hope I will apply their libraries and use it in our playlist. So yeah, my point, this is a physical robot what emits data from his perceptions, from his sensors to the remote. And for example, you can create an application on your iPhone, on Android device, and build some charts. In the next lesson, we will use a GPS position sensors, and you can track and build roads of your robot and monitoring it in real time. So this lesson, this part is very important to share the data between physical devices and the user of this physical device, the pilot. I believe that's all for today. Thank you guys, and yeah, see you soon.